Okay, we're continuing with our econometrics final review. For question 19, we can recognize this as a log-lin model or a growth model since we have time as the independent variable. It's asking what the coefficient on time means. Now we know that since this is a growth model, we know that we can interpret the slope over here, the slope value of 0.054, as a growth rate. So we can say that the instantaneous growth rate is equal to 5.4%, or alternatively, as time goes up by 1 year, predicted y goes up by 5.4%. Now it's giving you here the original formula. So before taking natural logs in order to run the regression, and we should recognize this as just a typical growth model where we have yt is equal to the initial value of y times 1 plus r to the power of t, where t is time and r is equal to the compound growth rate. So if we know that this is the original formula, we can go back and calculate the compound growth rate using this value over here. So how do we get to the compound growth rate from the instantaneous growth rate? Well, we take the natural logs at both sides if we don't remember the formula, and recognize that the intercept over here, beta naught hat, is equal to the natural log of the initial value of y, and that the slope, or beta 1 hat, is equal to the natural log of 1 plus r, which is the compound growth rate. So knowing this, we can solve for r, and so we find that r, the compound growth rate, is equal to e to the beta 1 hat minus 1. And the compound growth rate is always a little bit higher than the instantaneous growth rate, but pretty close in value. And we do see that here. We see that r is equal to e to the 0.054 minus 1, or 5.5485%. You're next asked for the predicted initial value of y when time is equal to 0. So if we plug in 0 in the equation, we're left, so this falls out, and we're left with the natural log of y is equal to 3.5. And so the predicted value of the initial value of y is simply equal to e to the 3.5, or 33.1155 units.